All right, so chapter 9, lesson 1, surface area prisms. Sorry, Timmy, we are still working with shapes.
When are we going to be done working with shapes?
Never.
I don't want to stop working with shapes.
Never.
I do. This is fun.
All right, here we go.
Do you have a math test graded?
No. All right, so chapter 9, lesson 1, surface area of prisms. Before we can move into this, everyone has to know what a prism is. Okay, this chapter we're going to be working with prisms and with pyramids. Okay, I'm just going to draw two shapes. Nobody asked. I said I'm just going to draw two shapes, so.
Oh, is that a prism?
No.
I said I'm about to draw two shapes. Nobody asked any of y'all to say anything. Goodness gracious. Which one's a prism and which one's a
The
pyramid?
left one,
That
one's a, the right
one's a pyramid, and the right one's a
The
prism.
left one's a triangle. I mean, a
What's this? What's this?
prism.
What's this?
A pyramid.
Pyramid. It's not a triangle. Now, Timmy, can you tell me what the difference between those two are?
one looks like a square.
Okay, be more specific about the differences.
One has 4 sides. I don't know, Miss Pence.
Promise. Excuse me. I'm talking to Promise and nobody else. That means none of you should be talking.
Like all the sides lead to one specific point.
So on the pyramid, they're all going up to one point.
And then on there, it's like more.
Okay. Who can be even more specific? Man.
Okay, so the only thing I can think of is that the cube, I'm just going to call it a cube. Just let me call it a cube. Just let me do it.
Okay.
Okay, so the cube has the same shape on every side.
Okay.
I mean, if you want to call it a rectangular prism, you can. I'm too lazy for that.
Okay.
And then the pyramid, which you could also call a triangular prism if you wanted to.
Actually, you can't call this one a triangular
Oh, yeah, you're
prism.
right. You can't. Never mind.
But we could call it a rectangular prism. You're right.
Anyway, so, and the one on the left has different shapes on different sides. It also has less sides. It only has 5 sides. The other one has 6. I know that's
Right.
not specific enough for you.
No, that is. That's good. I'm going to elaborate on that a little bit. Man said one of them only has five shapes on it, and the other one has 6. Who can explain to me why that one only has 5 and this one has 6? What makes the difference? Andrew?
Well, that one, okay, the prism, all the sides are equal, but with the pyramid, all the sides are equal except for the bottom one.
Kind of, yeah. Nate?
It's a triangle. It's like has a point
Okay.
at the top, and it doesn't have a base on the top. And a
That is what I was looking for.
I see your.
Okay. That's what I was looking for was the base. Okay. How many bases does a pyramid have? One. How many bases does a rectangular prism have?
6.
No. All sides aren't bases.
2.
Because technically, listen, if it's a rectangular prism, that means that the bases are the same. So the base would be
On top and the bottom.
here and here. So these two bases are connected by these lines, aren't they?
Right.
Those bases are connected by those lines. All right?
Oh, wow.
So when you put all those lines together to connect the two bases together, it ends up making 4 more rectangles, right?
Right.
Okay, so what y'all were getting at was this one has triangles on the side because they're all meeting up at a center point, right? So a pyramid has triangles around it, but what does a prism have? Rectangles around it. Yes, ma'am.
So if you had a cube and you said that the tops and the bottom were bases, if you flip it, doesn't that change where the bases are?
But if it's a cube, all of them are the same, therefore it kind
That's
of
my point,
doesn't.
though. It's kind of weird. It's like,
Miss Finn,
oh, these
is that
show this, never
triangle
mind. These show this, never mind.
We'll get to it whenever we have to. All
Mind.
right, we'll get to
Miss Finn,
how I draw it
what
whenever we get to
happened
them.
to the triangle?
What do you mean?
It looks a lot different, and I can't find the base anymore.
The base is right here on the pyramid.
Okay, how do we draw that? So you draw a square.
You draw a flattened square,
Square.
okay? Then you go to the middle of the square and you go straight up. I didn't go straight up very well. But you go straight up, okay? And you put a dot somewhere above it, okay? And then from that dot, you draw a line to every corner of your flattened square.
Yay. That makes a lot of sense.
Okay, well that one side's kind of.
No, man.
All right? And that's how you make a pyramid.
Well, that looks like a. Oh, I see it. I see it.
hmm And to make a prism, prism's even easier.
Just make two squares and connect them.
Right. When I make a prism, instead of my top and bottom being my bases, I pretty much make my front and back my bases whenever I'm drawing it. So I draw two bases first. So I'm actually going to make this one rectangular. So I draw a rectangle here. And then I start at the middle of this rectangle and try and draw another rectangle about the same size. So you see how I'm in the middle of this one, and that's the corner, right? And I draw that. And then I connect the corresponding corners together. So those two go together. I tried. Those two.
That actually
Those
turned
two.
out good.
Okay, so that's how you make, right. And that's what rectangular prisms are. That's what boxes are. Boxes are rectangular prisms. Sometimes boxes are cubes. What's the difference between a rectangular prism and a cube?
A cube is like
Square.
tiny.
A cube has all the same sides.
Every single side is the same. It doesn't just mean that the bases are squares. It means that the length, width, and height are all the same number. Now, because you can technically not only have a rectangular prism, you can also have a square prism, where your length and width are the same, but the height is longer. Yes?
Okay, I'm sorry, this makes me so angry. It's length, width, and height. And the height is not a word. I'm so sorry. I had to.
And really frustrating.
Well, I'm from Mississippi, so I say height.
No, it's not a word, no. No,
Height,
English
no.
word.
Technically, ain't isn't either, but I still say it.
No.
Ain't is a word.
It's not a word.
Ain't
Y'all
is a
use
I
word.
swear, by the end of the year,
No,
you
I
can
said
Alright.
the word ain't isn't a word.
Moving on. Moving on.
No.
Hey, moving on. What'd I just say?
Moving on.
So stop talking. Now, words says surface area S of a rectangular prism is the sum of the areas of the bases and the lateral faces. That's not just a rectangular prism. That's any prism. You don't have to write the words down. What I want you to write down is what I'm underlining. Surface area of a rectangular prism and this formula right here. S equals 2LW plus 2LH plus 2WH. My L's are in cursive, so they don't look like what? Ones or I's, right? Okay? I would not draw a capital L because that stands for something completely different. It doesn't stand for anything in particular, but when y'all get to geometry in 2 years, capital letters mean something different than lowercase letters.
Isn't
Why
like
couldn't we
geometry-
just label all of the bases and stuff? Why couldn't we just label them X, Y, and Z? Or heck, why couldn't we just add them all up?
X,
and
Y,
have
and Z.
that?
Well, you can, but it's just sometimes it's easier to know this formula as opposed to drawing out every single shape, finding the area of every single shape, and then adding every single shape together.
Yeah, no, I just like.
Now you can do that.
Easier for me to just look at the sides. and-
Right, if you don't remember the formula, you can always do that. Now this formula only works with rectangular or square prisms, okay? It would technically work with a cube too, because a cube is a square prism, isn't it? It's also a rectangular prism, okay? It's just a special one that has all equal sides, right?
Right.
Because remember, a square is a rectangle, isn't it?
Yeah.
Yeah.
Okay,
But
so,
rectangle's not always a square.
exactly. All right.
No, please don't.
So what's happening here when we're finding the surface area of a prism? We're not finding how much the prism can hold. For instance, I would not be finding how many balloons I can fit into this room. That would be volume, right? Figuring out how many balloons fit inside this room is volume. Instead, I might want to know how much paint for the entire room. Let's say I was painting the ceiling and the floor too. Okay, so I'm finding just the walls for surface area. I'm literally finding the area of every surface.
Oh, that's what?
That's what surface area means. So how many, let's pretend like that door's not there. How many surfaces would be in this room?
6.
6. Ceiling.
Paint the floor.
I'm just saying if we were painting the ceiling and the floors.
Oh,
Ceiling.
actually.
I said if that door didn't take, you missed that part. I knew you were going to say that. That's why I said it.
Actually.
I knew you were going to say it. That's why I said, let's pretend like the door's not there.
This is my room, that's like the door.
So ceiling, floor, wall, wall. Is the ceiling and the floor going to be equal?
No, yes.
Yes, they are, aren't they? Okay, that's why there's 2 of each one, because the front and back are equal and those 2 sides are equal. That's why there's a 2 in front of all of these, okay? That way we don't have to add it twice. We can just multiply it by 2. Okay, so we're finding the area of every single shape. But here we don't have to do that individually because we can just use length, width, and height. Height to do that. All right.
That's funny.
Man, what if I have a lisp and I just can't help but say height?
Well, that's
It's okay if you want to. I'm just saying.
All right.
Life, you know?
Try and draw this one for me.
Oh,
Part of your notes. Y'all remember to draw this.
draw a rectangle.
Rectangle here.
Aw.
Rectangle here.
This is a bad rectangle. Good lord.
And connect.
Oh, that's
I better put Miss Finn's class challenging on that.
I put challenging, but I love it.
I can't draw this.
I just showed you how.
I know,
Literally
but
draw, oh my goodness. Line, 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 line. It's ugly, but it works.
Y'all, my parents were teaching me how to draw these things when I was 3.
Yeah, well, I'm not a good drawer.
I can
Even when
just
somebody
not draw
shows me
this
how to
Drawer is
draw.
not word.
Drawer is not word.
You know what?
You're not an artist.
Drawer
Hey,
is not
do as I
word.
say, not as I do.
Like a
Okay.
drawer? Or like a say not as I do.
Okay. So anyway, attempt to draw that to the best of your ability, Timmy. Best of your ability.
I know the what
All right.
ability.
So our formula is 2LW plus 2LH.
What is LW plus LH plus WH?
L and W stand for length and width, length and height, width and height. Notice there's only 2 L's, right? We don't want 3 L's. 2 W's. Okay? And 2 H's. If you ever look and you've accidentally written down 3 of any of those, you probably messed up somewhere. So look and see what you only wrote down once so that you can then replace one of the 3.
Wait, but 2LW isn't the same as multiplying.
It is. Watch. LW, length times width, is the base.
I know, but that's multiplying times 2 though. Oh, because there's 2.
Because there's 1, 2 bases, right?
Wait, is the length
So,
the
hang on. The length and width don't really matter, like which one you choose for which, because it all depends on your perspective. Okay? So if you look at width as how wide something is going this way, okay, some people would call that a length as opposed to a width. Okay? Some people look at length or look at width as how deep back it goes. Okay? It's all based off of perspective and how and what object you're particularly looking at.
So that don't even
Okay.
matter.
Right, because 3 times 5 and 5 times 3 are the same thing, aren't they?
Yeah.
So it doesn't really matter. Now we can look at it as width being how deep it is and length being how long it is. So the length would be 3. So 2 just comes down, and then for L I'm putting 3. And the width would be how deep it is.
5.
Yeah, 5.
So it's 3.
Plus 2 times length again. We've already established that length was
3.
3 and width was 5. But we have a height as well. Height is always the distance between the 2 bases. Here's a base, Here's a base. What's the distance between them?
6.
6. So the height is 6. Okay? So 2, L is 3 again. Height is 6. Width was 5. And height was 6. Now, you can type this straight into the calculator, but the math is pretty simple too. Yes, Jonah? No. All right.
How did you say that? Calculator?
Yeah, you just type in 2 times 3 times 5 plus 2 times 3 times 6 plus 2 times 5 times 6. Again, the math isn't hard. 2 times 3 is
15.
6. And 6 times 5 is 30. Plus 2 times 3 is
6.
times 6 is
36.
plus 2 times 5 is
10.
times 6 is
60.
and now 30 and 36 make
66 to 100.
and 60 and 60 so yeah 126.
How did I get 150?
I don't know.
I don't know, but it works, Miss Finn.
I know it does.
This calculator's smart.
All right, so 126. Now, because this is surface area, it would be 126
Inches squared.
inches squared. It won't change to a cube until we're doing volume. What's wrong, man?
So I don't know how I got 150.
Did you type it in the calculator or did you do it in your head?
Did it in my head, but
Like it shouldn't work.
That's your
Remember,
problem,
it's simple.
man.
Look, all 4 sides that are on the side, all the blue ones besides the base, are all 30.
The front and back are going to be different, though.
30, 30.
So front and back are
6 times 3 would be 18 and 2 18s. Yeah.
This is my.
So you were assuming that all of the sides were the same.
So the way I drew them, they look the same.
I sketched a skeleton.
All right. You have to remember, though, man, once we start getting into geometry, you can never look at it the way it looks. Nothing is ever drawn to scale. All right? We try to draw things to scale, but there are going to be times, especially in geometry, when we're going to draw things exactly not to scale, so you have to use your definitions to figure it out.
So basically, when we get to the geometry, the entire world becomes a weird psychedelic.
Basically, you're going to hear Miss Suttles say a lot, never assume. Never assume. She's going to be your geometry and algebra 2 teacher. She's awesome. But you're going to hear her say, never assume. So when she says, how do you know that's 90? You can't say, because it looks like 90. You have to say, because there's a box there, and that box means 90.
Yeah.
Or there's going to be some other theorem that's going to explain, if these two things happen, then this is 90. You'll have to be able to tell her that. You can never just say, well, because it looks 90.
I hate it when there's no box in one of the angles, and you need that angle to figure out what it is, and it looks like a right angle.
Did you say
But,
angle?
and you need it.
Hey, hush.
Like it's either like 98 or 91. And no, I didn't say angle. I don't know why people care so much when I mess up. Nobody cares when other people mess up.
I mean, you cared when Miss Finn messed up.
Yeah, you can.
Moving on, as I said, moving on. I'm held to a higher standard than y'all are, so hush.
Dang. Sorry. Why do you want to
Why are you danging me? I roasted myself, so hush.
Why do you care for double standards?
Yeah.
I was basically saying.
And
Number one.
Nobody said, did you say double standards? I'll kill you.
Y'all, man, don't say I'll kill you. That was recorded.
I recorded.
All right. Hush, please. Hush, please. Hush. What's the length?
2,
What's the width?
3,
Do we have to write this down?
What's the height?
4.
Write this down and then write down your formula and solve it.
Got it.
Y'all should already have your formula written down because you have it in your notes.
Do we have to memorize this formula?
No. I'll put it on the board.
Cool.
But it's not hard to memorize.
I mean, I think it's pretty hard to be a little bit shy.
Because there's 2 of each letter, and then there's a 2
But
of
it's
each.
Exactly.
Okay. 2 times 2 is 4. 2 times 3 is 12. Plus 2 times 2 is 4.
Can you like work in your head?
For real.
What is 6 times
Yeah, we don't want to hear.
Wait, so if you were starting with the calculator and we were doing the length and width to begin with,
Okay, you ready? Here's how you're going to do it if you don't want to look at your formula. You just want to... So you've got these written down, right?
Yep.
2 times 3.
2 times 3.
You got 2 first, right? 2 times 2 times
So it'd
3.
be like, how do you do that? Like just
Press 2 times 2 times 3.
2 times 2 times.
Does it really
Okay.
matter what order
Plus.
it's in?
Two.
Now, still with length, right? We got length with W. Now we got to get length with height. So 2 times 4.
And then plus.
And then 3 times 4.
Hang on.
2.
Plus 2. And now we got to move on to width.
So
3 times 4
So it'll be plus 2 times 3.
times the height is 4. And we wouldn't do width and length because we technically already have that.
And then that's it?
Yep.
Okay.
I got that too.
All right. So we should have gotten 2 times 2 times 3 plus 2 times 2 times 4 plus 2 times 3 times 4. No minus. 2 times 2 is 4 times 3 is 12. 2 times 2 is 4 times 4 is
16.
2 times 3 is
6.
6 times 4 is
24.
24. 24 and 16 make 40.
40.
And 12 and 40 make 52.
Why did I write?
Square.
I'm not sure.
Oh,
Y'all okay on that one?
Pretty much.
Easy peasy.
Easy peasy,
I feel
but
like-
let's go easy.
Are the triangles going to be different?
Yep.
Can't squeeze lemonade.
You
Yeah.
can.
Who says you can?
All right. What's your length?
You squeeze the lemons, but you
What's your length?
Eight.
and then
What's your width?
Eight.
What's your height?
5.
Not on this one. On this one, technically, no matter what way you're looking at it, the length is 8 and the width is 8.
unless you flip it like
Unless you turn it this
and
way and then it's 5 and 8. Yeah.
I'm just saying.
But because this whole formula is multiplication and adding are commutative, so does it really matter?
No.
No, I just
No.
have trouble with this because I'm like, wait, which one is the length and the width? What do you
Well, that's why I was saying for these it doesn't matter because it's all based off of perspective. I said that at the beginning of this lesson.
Yeah, I know.
What is
Okay.
64 times
Is it-
You ever have to like write down the shit?
Got a calculator.
I'm gonna be like, oh no.
Technically, man, you could have written that the length was 5 if you wanted to, and you would have gotten the same answer.
You're so helpful. Like, honestly.
No.
Going back here.
Shoot. I probably typed it in wrong. 'Cause I was like,
You environment.
I did something wrong. Or I did something.
How do you figure this out?
Type it on the calculator.
Jordan.
Well, one, you've got a formula, and you just plug in L, W, and H into your formula. I just so happen to have the formula memorized.
Because you're a math teacher.
Exactly. I have lots of formulas memorized.
Tell me all the formulas in math. I'm just kidding. Don't do that, please.
Yeah, Nate's brain would explode.
That's a lot of fun.
What brain?
Yeah, there. I mean, I can't name
That's
all
why I
of
said
them,
his
but
brain would explode. It was very small.
Would this one be like meters high?
They have the fact they have to explain it.
That's why I got this right.
Can I
Is it
answer?
I'm not gonna
288?
say the answer, of course.
Can I answer this?
See what I tell you.
What is it?
288. See, two.
I was gonna let Sarah do it, but
Boom. 288.
Meter squared.
I
I can answer that.
I got 576.
You typed it in wrong.
you probably typed more timeses than
You
pluses.
hit 2. You
I
didn't do 2 plus 2. You did 2 times 2.
No, see, look,
Next
I
one did
did.
2 plus
Hey,
2 times 8.
stop.
8.
This is why I would rather you just do it in your head.
But like,
Because if you type it in the calculator, if you type one thing wrong in the calculator, y'all, the calculators were made to make your life easier unless you're in too big of a hurry. And problems that are as simple as this, there's absolutely no reason for you to have to sit there and type that into a calculator. It took me just as long to write it all out as it will take Timmy to type it all in a calculator correctly.
Well, the calculators are meant to make your life easier until you have to use 2 sets of parentheses for the same problem and then just make your life harder.
Exactly.
Actually, parentheses at all. I have to go out of my way to use parentheses.
Well, you don't even have to use parentheses on these. You can just do 2 times 8 times 8.
But that's what I've been
Yes,
doing.
promise.
Wait, why is this in the second power?
Because it's still an area, so we're finding the area of each one of these sides. And area is length times height. So anytime we're multiplying two things, it becomes a square.
Wait.
And then we're adding all the squares together so it stays square.
It's easier.
Now, once we do volume, we'll be multiplying 3 things together. So instead of a square, it'll become a cube.
So this is a cube.
Huh?
So this is a cube?
No, because we're not finding the volume. See, we're only multiplying two things together at a time, right? The 2 just represents that there are 2 of them, right?
Okay.
But this is your length and width. So we're only multiplying 2 units together. So that would make it a square. Anytime you see area, it's square.
And perimeter's not.
Right. Well, yeah, perimeter's 1, but yeah. All right. Surface area of a prism.
Oh no.
I just want you to write down what I underlined. You need to write down surface area of a prism first. Y'all, please, you don't have to read it out loud. Just write it down. Yes?
There are a ton of notes from last chapter that are just falling out.
Do you have a pocket?
I do, but it's full and broken also, and we'll probably.
Oh, do you have a back pocket?
I mean, I have a back pocket, but that's broken.
Oh.
I mean, I can't put it in there. I already
Would you like to staple them?
Hey, you just throw your.
I can staple. I can let you borrow my stapler.
No, it's okay. I'm just gonna put them in there. I like really use the notebook anyway. I just
Okay.
make the notes because I got it.
Yeah, you know. Oh, I keep meaning to bring my notes from when I was in 7th and 8th and 9th and 10th and 11th and 12th grade. I saved all my notes. Because I knew I was going to go do something with math. And I said, well, maybe one day I'll need these notes again. And guess what? I did. Because I actually looked at my notes and reused them.
I just throw all my notes away and all my
The only thing I look at after school is the back of my eyelid.
Because even when I was in college and I was doing something and I had to remember something like something that I learned in Algebra 2 but I hadn't used since Algebra 2, I called my mom and was like, hey, can you mail me my notes? They're in this drawer. And she mailed me all my notebooks. So I have them. And it was very useful. And when I took calculus in college, I technically took calculus in high school too. So I was trying to remember how to do something before she taught it. And since I already had the notes, I could do that. And she taught it differently than I had learned, so I was trying to remember how I learned it.
She calls division so weird.
I call it calculus.
Now use dots to represent division or whatever. Now put them in groups. How many groups can you put them in?
Oh, I was trying to show like a 4th grader how to do division, and she said I did it wrong because I put a 0 in one place.
Nice.
Oh no, I forgot to put a 0 and it was like before the problem, it was just holding in place. I'm like, there are so many short rectangulars.
Yep. All right. Stop talking. Stop. Okay. Surface area of a prism. Obviously, this is meaning for anything other than a rectangular prism, right? Which means also rectangular prism is also a cube and a square prism, right? Because squares are rectangles. All right. So now we're going to be talking about prisms that have a base other than a rectangle. For instance,
Oh, it's gonna be a triangle.
It's a
That's a
triangle.
triangle. That is not. Two triangles. Oh, I know.
It's gonna make a pizza.
Oh,
No, it's not.
No, it's not. It's
gonna
gonna
be a
make like a mailbox.
I tried. Anyway.
What is that?
Where's that? It's like, you know that, okay, imagine.
Okay, let me try again.
A long triangle.
See what y'all did.
Oh wait, how do we bring
there we go.
You don't know how to draw that? That's better.
Oh!
All right. Thank you. Thank you. I know.
Wait, but
I know.
the base is
Brilliant.
still a rectangle.
No one cares.
No, it's not. Okay, I'm glad you brought that up, Aiden. Okay?
Yeah, it's all.
I said no.
The bases, remember the bases now, you're going to be able to tell, listen. I get interrupted one more again. You'll always be able to tell what kind of prism it is based off of the shape that's different. There will always be two shapes that are different. Remember, in a pyramid, the sides are all triangles, right? And the bottom is different. Okay, the sides are all triangles. But in a prism, the sides are always rectangles. And the bases might be rectangles, but they could be any shape you want. I could have made that a hectagon if I wanted to.
That's a prism right there.
Wait, so we're either looking at it from like a top angle or a below?
Side.
Upside down angle.
But now,
But now nothing, just go with it. It's not a house. It's a basement.
Is this how you draw a house, by the way?
How I draw a house. That's so.
Okay. That would be a pentagonal prism
Pentagonal.
because it has 5 sides. The base is a pentagon. All right. So you can draw your bases into any shape. Stop. If it's not yours, don't touch it. Ridiculous to have to tell 7th graders that. Okay? We're going to be talking about triangular prisms because y'all don't know how to find the area of a pentagon. You can find the area of this one because it's a square and a triangle, right? But not all pentagons are going to be able to be broken down into that. So we're mostly going to be working with triangular prisms because you do know how to find the area of a triangle. Right. The area of a triangle is base times height, or length times width divided by 2. Remember, the length is going to be horizontal, all right? And the width is going to be vertical. So basically your length and width are going to come from the 90-degree angle, all right? So this, they're going to give you a number for this side. But is that length or width?
No.
No, you need this side because we're going to have to find that rectangle. Okay? Now, there is no special formula for a triangular prism. In order to find a triangular prism, we are going to have to take the entire thing apart, redraw all the shapes, at least until you get good at it, okay? And then add them all together. So, we always start with our bases. Our bases are what?
5 and 3.
What are our bases? What shapes are they?
Triangles.
Triangles, okay? So I'm going to draw my 2 triangles. And they're right triangles, aren't they?
Right.
I know that because they're a right angle. And remember, the length and width comes from the right angle. Do we use the diagonal as a length or width?
No.
Not for the triangle, okay? So what is this on our triangle in our picture?
5. Not 5. No. It is 3.
Which matches that, 3. And if that's 3, remember the bases are the same, so that one's 3. What's this length?
4.
Right. It's this, which is also that, which is 4. So now, how do you find the area of a triangle?
Based
Base on height divided by 2.
So 3 times 4
12.
divided by 2.
6.
So 6 and 6.
I used to
Now,
pre-design.
now, stop talking so I can teach. Gosh. How many sides are on a triangle?
3.
3. Okay? All of those rectangles are connecting the 2 triangles. So if it's connecting completely, there is a rectangle for every side, is there not? You may only see 2, but there's really another one
Because it's behind it.
at the back.
That makes sense.
Okay? So it's a big one at the back. So what I'm going to do is draw that, and I'm going to write back so I know which one that was. Okay? So the base of the back, what is this length?
5.
It matches up with this one, which is 5. And now the side, what is the side?
6.
6. Fun fact, the heights of all of the rectangles are going to be what? 6, because all the rectangles are the distance between the 2 bases, aren't they? So all of the heights are going to be 6. It's their bases that are going to change.
I was about to say, couldn't we just find one rectangle and multiply, but we can't because they'll have
We
different
can't
bases.
because as long as all the sides on the triangle are different, that means all of the rectangles are different. So now let's find the the left side. Okay? So left, what is the base?
3.
And the height is
6.
6. And then, did I use green? No. And then we'll find the right.
That is right.
That was
Okay.
We all expected that.
Well, you ain't got to know my name.
No, stop.
So the green one, what is the base?
4.
And what is the height? 6. Again, notice all of those were the same. How do you find, I don't know why you're packing up. I understand you have less than a minute, but that's my time. How do you find the area of this?
Based on height.
So what is it?
30.
30.
What's this?
18.
What's this?
24.
Wait, why was the
So-
right one different than the left one?
Because we already explained this.
Different sides.
As long as the triangles have different lengths, the rectangles are different. The heights are the same, but all the bases are different because the bases come from the sides of the triangle. Now, what do we do after we find the area of every single side?
Add them together.
You add them all together. 6 plus 6 is
12.
plus 30,
42.
42, plus 24,
50. 64.
60.
No.
66,
Oh,
66.
plus 18,
70.
76, plus 8,
84.
84. So it would be 84.
Just
Will we do meters squared?
Yes.